Well, how do you like that? It turns out that the natural log of x is not what we had in this moment. You had to watch the video with Desmos to see that we actually had to shift this polynomial to the right 1 unit. And so this quantity of x minus 1, yes, x minus 1, does shift the Taylor polynomial to the right 1 unit. To see that we do indeed have a nice Taylor series that would look like this. The infinite Taylor series would be the sum as n goes from 1. I prefer counting at 1 because what we have is 1 over n. When n equals 1, 1 over 1 times x minus 1. When n is 2, 1 over 2. When n is 3, 1 over 3. When n is 4, 1 over 4. Remember that when we count terms using n, we're saying this is the first term. That's what n equals 1 means. It just means the first term. When n equals 2, we've got the second term. When n equals 3, we've got the third term. When n equals 4, we've got the fourth term, etc. And so, yes, the Taylor series would be from 1 to infinity, 1 over n, and then x minus 1 to the, notice it's to the first power, to the second, to the third, to the fourth, so just to the n power. But then don't forget the alternating nature of this thing. We need that negative 1 to the, and you saw in the previous video, to get the signs to work out properly, we need to the n minus 1. All right, awesome. But you also saw that as I Desmosed this thing to greater and greater and greater powers of n, that the polynomials seem to converge only when x was between 0 and 2. So what's up with that? So I have some algebra here to show you. Actually, yeah, mostly algebra. It's known as the ratio test. And the ratio test will help us figure out for what values of x does a series converge. So we're going to apply the ratio test to that Taylor series. N goes from 1 to infinity, 1 over n, x minus 1 to the n, negative 1 to the n minus 1. We're going to apply the ratio test. The ratio test says this. Take the ratio of a sub n plus 1 to a sub n. Now remember, the a sub nature is just the terminology or the symbology we use for sequences and series. When you see a sub 1, that's just a reference to the first term of the series. So we saw that the first term in the series was 1 over 1 times the quantity x minus 1 to the 1, or just x minus 1 to the 1. If we said a sub 5, we're talking about the fifth term, etc. So a sub n plus 1 is the next term. For instance, if I had a sub 6, a sub 5, do you see how, using the notation back here, n is 5, n plus 1 would be 6. Or if I had a sub 21 and a sub 20, n would be 20, n plus 1 would be 21. So one way we can think about this is it's saying take the term in a series that you like and compare it as a ratio to the term right before it, or the term and the term right after. These are subsequent terms in the series. Find the absolute value of that ratio and let that ratio run off to infinity. In other words, we're not going to do a sub 6 to a sub 5 or a sub 21 to a sub 20. We're going to do like a sub a bazillion to the term right before it, a sub a billion minus 1. And if that ratio is less than 1, then the series converges. Now, based on Desmos, it appears as though everything I've listed right here is true only when x is between 0 and 2. So we're going to find that out. we're going to work this thing out algebraically to confirm what we see on Desmos. Now, I got to be honest with you. I'm pretty convinced by what I saw on Desmos. I'm pretty sure that what we call the interval of convergence is the interval from x equals 0 to x equals 2. Remember that we centered this polynomial at x equals 1. So from 1 to 2 is 1 unit, from 0 to 1 is 1 unit, and so we would say the radius of this convergence is 1 unit, meaning 1 unit either side of the center. From 1 to 2, from 1 back to 0, the radius of convergence is that 1 unit. But the interval of convergence is 0 to 2. I saw it on Desmos. I'm just going to back it up with the algebra. So the algebra looks like this. Hey, let me actually start it here, and then we'll go for it. I'm going to do it in this color just to kind of highlight all the theory above with the actual work here below. So we're going to take the limit as n goes to infinity. We're going to find, or at least express, the n plus 1th term of this series. So the series was, and it's an absolute value, the series was 1 over n, but now we're talking about n plus 1, the next term in the series. And then we had x minus 1 to the n plus 1, times negative 1 to the n plus 1, minus 1. Notice everywhere there was an n, we're now replacing it with n plus 1 to represent that a sub n plus 1, the n plus 1th term, the next term in the series. Compare that as a ratio to the term a sub n. So just leave it 1 over n, x minus 1 to the n, negative 1 to the n minus 1. So this formula is a formula for the nth term. That's the denominator. A sub n plus 1 is the next term. Replace all the n's with n plus 1. All right, now we just need to do some algebra to make this thing seem a little bit more clear. So for instance, look at this. Can we just think through this a little bit? If you had x minus 1 to a power divided by x minus 1 to a power 1 less. Just as an example, if you had x minus 1 to a power like 10, and then you had x minus 1 to a power 1 less. I hope you see what I mean. N plus 1 versus n. This power is going to be 1 more than this power. So if I had x minus 1 to the 10th compared to, as a ratio, x minus 1 to the 1 less 9, what would happen is this is x minus 1 multiplied 10 times. This is x minus 1 multiplied 9 times. The x minus 1s would all cancel out except for the one additional one in the numerator. All of this would simplify to be just x minus 1. And that would be true for anything. I know I picked 10 and 9 just to make my brain think, but it could be 101 versus 100. 100 of those x minus 1s and the 100 x minus 1s in the denominator would all cancel out, leaving you just a single x minus 1. So my first move, let me just take this to the next page so it's a little neater. My first move is the x minus 1 to the n plus 1 divided by x minus 1 to the n is going to simplify to be just x minus 1. All right. Another thing, what about this negative 1? Let me do that in red. What about this negative 1 business? Notice in the numerator, n plus 1 minus 1, or just negative 1 to the n plus 1 minus 1, that would just be n. And then negative 1 to the n minus 1. So again, notice that if this was like a 10, this would be a 9. 1 less. If this was 100, this would be 99. So the numerator would have like 10 power, a negative 1 multiplied by itself. Negative 1 times negative 1 times negative 1 times 10 times. The numerator would have 1 less. So all of these would cancel with all of those but the 1 extra because it's 1 power greater. So all of that simplifies to be just negative 1. And then 1 over n plus 1 divided by 1 over n. let me just squeeze that in down here. If you had 1 over n plus 1 divided by 1 over n, that's the same as saying 1 over n plus 1 times, do you remember you invert and multiply? Multiply by the reciprocal. So this simplifies to just n over n plus 1. So that simplified to be just n over n plus 1. Awesome. Now, notice it's n that's going to infinity, not x minus 1 times negative 1. And so what I'm going to do next is I'm going to pull out the x minus 1 times negative 1 in absolute value. It's all in absolute value. And let's just explore the limit as n goes to infinity for the part of the limit where that contains n. Now, what happens if n goes to infinity? All right, let's just come over here and explore for a minute. Say n was 1. n plus 1 would be 2. If n was 1, n plus 1 would be 2. So we'd have 1/2. What if n was 2? Then numerator would be 2. 2 plus 1 is 3. What if n was 5? Numerator would be 5, denominator would be 6. What if n was 9? 9/10. Do you see what's happening? 1/2, 0.5, 2/3, 0.6666, 5, 6, 9/10. What if n was 99? The denominator would be 99 plus 1, 100. 99 100s, 0.99. What if n was 1,000,000? The denominator would be 1,000,001. Can you imagine 1,000,000 divided by 1,000,001? What I'm trying to get you to see is, as n gets bigger and bigger, this thing just gets closer and closer to 1, the loneliest number that I've ever seen. And so what we have left is the absolute value of x minus 1 times negative 1, and then that limit all turned out to be 1, so times 1. And then going back to the theory of the ratio test, the ratio test has to be less than 1 in order for a series to converge. And so this remaining piece, we've taken the limit, n over n plus 1, the limit as n goes to infinity goes to 1. All we're left with is this thing has to be less than 1. Now we could simplify this, distribute the negative 1, negative 1 times x, negative 1 times a minus 1. This simplifies to just be 1 minus x. So in what situations is the absolute value of 1 minus x actually less than 1? Now, I'm going to do some quick algebra here. You can think your way through this, but maybe you remember this from your algebra days. If you take that 1 minus x and say less than 1, the negative x is less than 0. So then you divide both sides by negative 1, and when you do, you flip the inequality. Does that ring a bell? But then also, the algebra here is you'd have to say 1 minus x is greater than negative 1. Yeah, when you solve an inequality, there's keep it the same, and then there's flip everything around. There's some algebra behind that I'm not interested in discussing right now. But subtract 1 from both sides. Divide by negative 1, flip the inequality. Look at that. When x is greater than 0 or less than 2, this ratio will be less than 1. And so there it is, that 0. There was that interval of convergence that we saw on Desmos. Welcome to the ratio test.